today I will go into presentation the statistic assignment. So introduction, statistic also we collecting, organizing and also analysis the data obtained to get the best result. Through the data create statistic can help manager in terms of accounting, marketing, management, sales and order. Data that cannot be collected using experiment and survey sample. Statistics are divided into two types, namely descriptive statistic and iterative statistic. The prescriptive statistic is the description of the characteristic of the variables such as mean, median, mean, and so on. While average statistic is to describe the relationship between variables, for example, of t-test. So to fulfill the statistic assignment, our group decided to take the data from population age group in Malaysia, which is select data for the age category and ethnic for Bumiputera, Chinese and Indian for male gender in 2018. Using the available data in the Department of Statistics Malaysia, the study find the highest number of Bumiputera. So I think that's all for the introduction. Next presentation is data description. Frequency distribution is table that show class or interval of data entries is a class. For our assignment using the group data. Group data is a frequency distribution produced wherever observation also into class one of more than one value. Relative frequency. The relative frequency is the percentage of the data that fell in that class. To find the relative frequency of a class, divide the frequency by the sample size. Cumulative frequency is the cumulative frequency of a class is the sum of the frequency for that class and all previous class. The cumulative frequency of the last class is equal to the sample size. Now you can see our data. So this is our original data of population Malaysia in 2018. So you can see the Bumiputera is highest. Is 10,116.2, China 3,426.5, and Indian is 1,135.7. So to calculate the relative frequency, for example, of Bumiputera, frequency is 972.8 and the total is size 1116.2. So you can get the answer is 0.10. So the cumulative 972.8 plus 9,054.7. So you can get the answer is 400,853.2. So the China's frequency 173. So for the relative frequency, the same formula is, so you can get the answer 0.05, and cumulative for the class is 173. So the Indian, you can get the answer for the last class is at the relative frequency is 9.07, and the cumulative frequency is 1,135.7. So you can see the size at the same. So that's all for the presentation.
Hello, good morning. Today I will continue this part two, which is the data arrangement. So my name is Muhammad Syabi Amshah bin Samsul Amri, and my metric number A19A0374. So next, move on to the next slide. Frequency table. Frequency distribution. Frequency distribution is an overview of all distinct value in some variable and the number of time they occur. That is frequency distribution tells how frequency are distributed over values. Frequency distribution are mostly used for summarizing categorical variables. Relative frequency distribution is the portion of percentage of the data that fall in the class. Cumulative frequency distribution is the sum of the frequency for that class and all previous classes. The cumulative frequency of the last class is equal to the sample size. So we move to the first table, which is graphical method, and I do histogram. So the data is about 3 ethnic, which is Bumiputra, Bumiputra, Chinese and Indians, and we compare to only focusing for one one subject, which is male, only male for the sex. Okay, let's continue. So histogram, this is the bar that represent the frequency distribution of the data set for Bumiputra. So here, this is the year, the the age. So from 0 to 80 and above. So this is the class frequency, midpoint frequency and frequency cumulative. So next, move to graph. So this is the histogram. So when we look here, so this is the midpoint, which is age 2, 7, 12, 17 until 82. So here, the the value, the most age we got in this graph, which that show number 2, just to so wait for, so which is here we get 0.2. So we have 1015 1015 people, which is Bumiputra, at 2 age. So this is the highest value. So is for the lowest value, which is 77 male for Bumiputra. So here is the lowest value. So we next to the second graph, which is graph polygon, frequency polygon. For frequency polygon is a graph that emphasizes that continuous change in frequency for Bumiputra. So here we start from this. So here this is 1015 for 2 for H2, and the last is 87, which is 0. So the lowest at here 77, which is 82.2. So next, for histogram, histogram for the data for the Chinese in Malaysia. So here, okay, we move to the graph. Okay, so we look here. The highest number is here 27, which is 278.5 thousand people for Chinese in age average for 27, and the lowest is here, which is 60.3 60,000.3 for 82 age. So here we move to the polygon, and a frequency polygon is that's line graph that emphasize the continuous change in frequency for Chinese male in Malaysia. So let me see, before this, for 27 is the highest, and the lowest is 80 82. This is, so this at the end 87, so this is 0 and this is 0. So next we move up to the last data, which is for Indian in Malaysia, male Indian in Malaysia. Okay, sorry. All right, so this is Indian. So we can see that the highest number for Indian male in Malaysia is 90.7 thousand. So which is for age 32, and the lowest is 77, which is 8.8 thousand. So this is the, can we see the frequency for and the number of male for Indian in Malaysia, to compare with the three. This is for the number of Chinese is the largest number, because they have the the number of male in Chinese in Malaysia are more than Bumiputra and Indian. So we move to the last frequency polygon. Okay. So here, yes, in age 32. So have the highest number for which is 90.7 thousand. So the lowest is 77, which is 8.8 thousand.
Today,
So
I
thank
would like
you.
to present about the numerical descriptions measure. Okay. The mean, median, mode, range, variance, and the standard deviation are the most commonly used numerical measure for the quantitative data. Table of content. Uh, Table of content has three. First, measure of the central tendon. Second, measure of the positions. Three, measure of the variance. Okay, measure of the central. They have three most commonly using measure of tendon for the ungroup and group data are mean, medium, and modes. Secondly, measure of the position. Okay, measure or position give us a way to see where our current data, positions, and value fall in the sample or distributions. Okay, third, measure of the variance. Measure of variance is the sum perimeter intended to describe the amount of variance between random variables. Measure of the central tender have three: mean, mode, and medians. Okay, first, mean. Mean is the sum of the data entry divided by the number of the entry. Secondly, median of the value that live in the median of the data when the data set is ordered. Okay, mode is the data entry, the order with the great frequency. Measure of the variance has three. First, you need to find the range. Second, variance, and three, standard deviations. Okay, for the measure of position, you need to quarterly 1 and quarterly 3 to find the quarterly range is quarterly 3 minus quarterly 1.
Continue. My part is statistical analysis with software. We have numerical discrete measure, hypothesis testing, correlation analysis, and confidence interval. First of all is numerical descriptive. We have this amount. This amount. Okay. We have median 9, median mean 9. Also 2 for median and mean for ethnic, and for portion we have this amount. So basically we found that manual calculation and software is different, and multiply modes exist. The smaller value is shown. Okay, next for hypothesis testing, we have t-test and also ANOVA, and the confident interval of 95% difference is lower 7.61, and upper for age upper 10.39, and conclusion 199.902 for lower, and uppers 370.330. Okay, for ANOVA, for population between age, we found that the amount that we found a very difference between a population and ethnic. So population between age is between group 968825.70. Okay, and the total is 4589775.2. So on. So we move to correlation, and correlation is significant at the 0.01 level to tail. Okay, is to tail, to tail, to tail. Okay. So lastly, for confident interval population for ethnic, okay, 95% confident interval for mean, the lower boundary for Bumiputra 419.132, and upper bound 771.010, and the Chinese 95% confident interval for mean is lower bound 195.204, and upper bound 238.008. For Indians, we have lower bound for 4.272 and upper bound 73.069. So that's all for me. Thank you.
Now I will present about theoretical modeling. This is scatter plot graph. From the image, in scatter plot matrix, graph 1, plot age against ethnic. It can be seen that the age doesn't affect the increase in ethnicity. Graph 2, plot age against population. Not all age affect the male population in Malaysia. However, in 2018, at the age of 15 until 90 years old, which is Putra, 25 until 29 years old for Chinese, and 30 until 34 years old for Indian have affected the male population in Malaysia. The last graph, which is graph 3, plot ethnic against population. It can be seen that an increase in ethnicity will affect the population in Malaysia. Second is test of normality. From the table, we can see that the Shapiro-Wilk test of normality on the residual give a p-value of 0.302, which is more than 0.05. Thus, the assumption of normality of the residual term is met. Third is model summary. From the table, the R-square value is 0.726, which means 72.6% of the variation in population can be explained by age and ethnic. The Durbin-Watson statistic of 0.083 is not far from 1. Fourth is ANOVA. From the table, the p-value from ANOVA table is less than 0.001, which means that at least one of the two variables, age and ethnic, can be used to model population. And the last one is coefficient. The equation that we can produce from this table is population equal 1036.818 minus 26.913 for age and minus 268.2 for ethnic. Thus, for every unit in increase in age, population will drop by 26.913 provided the ethnic remain unchanged. Similarly, for every unit increase in ethnic, population will decrease by 268.2 units provided the age remain unchanged. That's all from me. Thank you.
For conclusion, statistics are the data obtained to an estimate or expectation. Statistical also design of a study to collect meaningful data to answer a focused research question. Detailed analysis of the pattern in the data and drawing the conclusion that goes beyond the observable data. We use random sampling to generate results for our research of the Malaysian male population in 2018 with three ethnic, Bumiputra, Chinese, and Indians. Based on the research we have done about the male population in Malaysia, we developed the data into two graphical forms, which is frequency polygon and histogram. This is because through this graph, we will get a more specific number for the total population. From the frequency table we have, we can create and calculate the mean, median, and mode number to get measure of central tendency. For chapter we apply for making the graph, and for chapter we also learn about the formula for mean, median, and mode. Lastly, has a SPSS output used to find the measures of central tendency and determine the shape of the data distribution. The statistical analysis using software also we use numerical, descriptive measure, hypothesis testing, ANOVA correlation analysis, and confidence interval to get a source for the data. Statistical conclusion validity is the degree to which a conclusion about the relationship among variables based on the data is correct or reasonable. Thank you.